So here's something completely new for you, the remainder theorem. So this is section 3.2. And let's go back to elementary and determine the quotient. So I'm going to just do a couple of these. This is long division. And when we're doing long division, I want to see how many times does 3 fit into 963. So first, how many times does 3 fit into 9? Well, it fits in 3 times. And then we'd go 3 times 3 is 9. Okay, do a subtraction. 9 minus 9 is 0. And then we would drop down the 6. So how many times does 3 fit into 6? Well, 2. Well, how many times, what is 3 times 2? 6. 6 minus 6, 0. Drop down the 3. Then 3 goes into 3 once. And 3 times 1 is 3. So we get 0. Perfect. No remainder. So 963 divided by 3 is 321. Not that special. Let's go look at the next example though. So how many times does 4 fit into 13? Well, it fits in 3 times. And 4 times 3 is 12. And then 13 minus 12 is 1. And then we drop down to 0. How many times does 4 fit into 10? Well, twice. And then 4 times 2 is 8. 10 minus 8 is 2. Drop down this 8. And how many times does 4 fit into 28? Well, 7 times. And then 4 times 7 is 28. Oh, there's no remainder again. Okay, let's try one last one. I'll let you do the last one on your own. So how many times does 3 fit into 2? Well, it can't. So we go to the next digit. How many times does 3 fit into 25? Well, 8 times. And 8 times 3 is 24. So 25 minus 24 is 1. Drop down the 2. How many times does 3 fit into 12? Well, 4 times. And what's 4 times 3? 12. 12 minus 12 is 0. Drop down the 2. And then how many times does 3 fit into 2? Well, none. So right now, we would have a remainder of 2 if I was to stop there. So remainder equals to 2. Now we could continue this on. We could put a decimal place if we wanted to figure out further than that and actually drop down this 0. So how many times does 3 fit into 20? Well, it fits in 6 times. So this is also going to be decimal, so 0.6. 3 times 6 is 18. And actually, we're going to end up with a repeat here. So we're going to end up again with 2. We could drop down another 0, but we'll end up in the same position. This is going to repeat. So it's 840.6 repeating. So why would we make you go all the way back to elementary to do long division? Well, because we're going to divide polynomials in Math 30-1. So we have x cubed plus 2x squared minus 5x minus 6, all divided by x plus 2. So we're going to compare mostly with this x. So x times what gets me x cubed? Well, x times x squared. So then I'm going to go x squared times x is x cubed. And then x times 2 is 2x squared. And just like before, we're going to do a subtraction. So x cubed minus x cubed is 0. And that's what we're looking for. Here we also do get 2x squared minus 2x squared is also 0x squared. And just like when we were doing without variables, you just drag down the next number. So we our term. So minus 5x. So we ask ourselves, x times what gets me 0x squared? Well, plus 0x. Now I'm going to use that as a placeholder. I understand that that's actually equal to 0. So then we go 0 times x is 0x squared. And then 0x times 2 is 0x as well. Then we do a subtraction, so we get negative 5x, and we drag down our last term, so minus 6. So we have to ask ourselves, x times what gets me negative 5x? Well, minus 5. So negative 5 times x is negative 5x, and then negative 5 times 2 is negative 10. And we're going to subtract those. Be very careful with that. I'll put brackets even here to make it more explicit. So this is definitely 0x because that's what we're going for. But negative 6 minus negative 10 is positive 4. Now that positive 4 is our remainder. So our answer then is x squared minus 5 with a remainder of 4. So I actually hit a little bit of the question on you. The second part says to label the division components, so dividend, divisor, quotient, remainder. So our dividend is this x cubed plus 2x squared minus 5x minus 6. Our divisor is x plus 2. Our quotient was the x squared minus 5, and then our remainder was 4. Okay, next, C, express the division using the division theorem. So P of x equals Q of x times D of x plus R. Then verify using left side equals right side. So P of x is our original polynomial, which is our dividend in this case. So we have x cubed plus 2x squared minus 5x minus 6. So that is our P of x. And then our Q of x, well, that's our quotient. So our quotient we found out was x squared minus 5. And that's multiplied by the divisor. So our divisor was x plus 2. So multiply by x plus 2. And then we need to add the remainder. So our remainder was 4. So what this is saying is if I multiply using FOIL these two factors and then I add 4, I should get back to my original polynomial. Now there's a second way to actually represent this. The division theorem also says that P of x divided by D of x, so our original polynomial, which was x cubed plus 2x squared minus 5x minus 6, if we divide that by the divisor, which is x plus 2, we should actually get our quotient, which makes sense. If we do the division, we should get our quotient, which is x squared minus 5. And then if there is a remainder left, in this case the remainder is 4, and then we divide that by x plus 2, because we were still trying to divide that by x plus 2 at that point. Let's put these in brackets here. So let's take a look at some more long division questions. It does want us to express them in the form P of x divided by D of x is equal to Q of x plus R divided by D of x. So as soon as I look at this, I'm going to make sure that these are actually have like cubed, squared, x, constant, perfect. There's no jumps in my exponents. And then I'm just going to rewrite this as a long division. So 3x cubed minus 4x squared plus 2x minus 1. So there's my dividend, and then x plus 1 is my divisor. So x times 3x squared is going to be 3x squared, or cube, sorry, 3x squared times 1 is 3x squared. So doing that subtraction, so we get 0, and then negative 4 minus 3 is negative 7x squared. Really watch with that negatives. Drop down the 2x. So x times negative 7x is going to get me negative 7x squared. And then negative 7x times 1 is negative 7x. So doing the subtraction. So this equals 0, and then 2 plus 7 is going to get me 9x. Dropping down the 1, negative 1. And then x times 9 is going to give me 9x, and then 9 times 1 is 9. So doing a subtraction. So 9 minus 9 is 0, and then negative 1 minus 9 is negative 10. So that's going to be a remainder of negative 10. And we're not done. It wants us in this form right here. So that's going to be P of x, so that's our original polynomial. So that's 3x cubed. That looks like a minus 4x squared plus 2x minus 1, all divided by our divisor, which in this case is x plus 1. And then our quotient, which came out to be 3x squared minus 7x plus 9. And then we have plus our remainder, which was negative 10, all over our divisor, which is x plus 1. There we go. So now we have it in that form. I should put some brackets here. So let's take a look at the second division we have to do. So x cubed minus 3x minus 2 all over x minus 2. Now last time it seemed ridiculous that, well, why would I say make sure that there's degree 3, degree 2, degree 1, constant? Well, here we're actually missing the x squared. So we're going to need to put a placeholder of 0x squared in there. So when I rewrite this out as x cubed plus 0x squared, now that's still equal to 0, that's why it doesn't matter, minus 3x minus 2, and that's all divided by x minus 2. So now same thing, x times x squared is x cubed, Now x squared times negative 2 is negative 2x squared. Again, I'm putting brackets just to really emphasize that that is a subtraction happening to everything. So that's 0, and then we get actually positive 2x squared. So then I have to drop down the negative 3x. Now x times 2x is going to give me 2x squared. And then 2x times negative 2 is minus 4x. All of that again is subtracted. So negative 3, it's going to end up being plus 4x. It's just a single x. And then we're going to take down this negative 2. And then x times 1 is going to get me x. So then we get x minus 2. So we actually have no remainder here. So that is our quotient. Now we're not done. We have to put it in this form. Original polynomial, which was x cubed minus 3x minus 2 all over the divisor. So that's x plus 1 equals to our quotient, which was x squared plus 2x plus 1 plus our remainder. So we have no remainder here, and then dx, d of x, which is our x minus 2.